Oh, you know how I like new toys and new gadgets, and this is my new one. And I love it, and I think you will love it too, so let's get started.
Login accepted.
As you know me, I like simplicity, I like simple things that were good, and I've never been a fan of bed probe because I've always run both of my printers with a very simple mechanical Z-stop switch, and it's been working great like that. I'm running aluminum Mixis ultra flat bed plates, and they've been good. I've never had any issues. I've always had very good first layers, so I've never felt a need for adding a automatic bed leveling probe on my printers, because yeah, it's been working great, and I didn't really like adding more weight, more complexity to the print head if I don't need it. But this beacon from Annex Engineering might have changed my mind actually. It's ultra light, weighing about 3.7 gram on the low profile version that we're going to use tonight. But it's also very simple. It doesn't require any docking system like we used to have on the quick draw probes or clicky probes, you know, where you have a docking system where the print head just go grab the probe the bed, put the probe back on the docking. So you need to have a servo motors, you need to have extra macros, you need to have, you know, added complexity. Not that it's super complicated, but it just adds more things that can fail to your printer, and I like simple things. So this one, the beacon, is super simple. You install it on your print head, it stays there, and it will probe the bed in a way that you've never seen before. At least I didn't see that before, and it's quite awesome, and it does it ultra fast, and you know how I like fast things. So I think you're going to love that probe, and we're going to install it tonight on my VZ235, and hopefully this video will help people to install it, configure it, make it work. So let's just get started and install that thing. Alright, the first thing I needed to do is to design a mount for it. On my side, I decided to put it on the part cooling fan dock. I think it was just the best place to put it on my side. And since beacon detects metal surfaces using eddies current, then yes, it will work just fine on a PEI steel sheet, unless you're using a bed plate that has embedded magnet in the bed plate. Then yeah, unfortunately that will not be working good with that setup. But if you use the standard magnet that covers the entire bed and you just stick it on the bed plate and put your PEI sheet on top of that, it will work just fine. So you're good to go. Just the one that I'm running on both of my printers. So they provided a CAD file that shows the clearance needed, and this is going to make it easy when you're going to design your mount for it. So just keep in mind, keep anything away in the surrounding area. You need to keep everything metal away. So that includes screws and stuff like that that are metal. Keep that away from the sensor because it's going to false. It's going to be affecting the reading in a way that it will have false reading. So that will make it easy with the CAD file, except when you have a full metal print head like the VZBot. It makes it a bit more complicated, but fortunately enough, the VZBot print head has a hole in the middle of the bottom plate, and I think this is a very good place to mount it, and that's what I've done. And it's going to need about 2 millimeters, between 2 millimeters and 2.6 millimeters away from the nozzle in terms of Z height. But I think their latest firmware has set it down to 2 millimeters. So 2 millimeters is where you need to aim for your mount. And the next thing for me was to desolder that board because I bought it, I pre-ordered it before we had a low profile version. So I needed to do desoldering and re-soldering in a low profile configuration so it clears the rear dock, the CPAP dock on my side. Good thing is we've worked with Annex Engineering and the Beacon guys, and they have made a new low profile configuration that you can buy directly from their website, and it's gonna be ready for you. You won't have to go through the pain that I had to go through to desolder and resolder that board, because I gotta admit, I'm not the best at doing this type of work, but I got the job done and it worked, so I'm happy with that. And also I had to reverse the pins on the USB cable, because when you put the connectors on top instead of on the bottom, the pins are reversed. So just keep that in mind if you have to do it like I did. Reverse your pin out, or just make sure you have the pin correctly good. So installing it on the VZ butt was very simple. Since it's using the fan duct, very simple stuff. Put it there, screw it on, connect it, and away you go. So now that we have the sensor installed, we are ready to jump into the Klipper configuration. And for this, I'm gonna walk you through the setup. Okay, Klipper installation is pretty straightforward and easy. You're gonna need your favorite web interface. In my case, I'm using mainsail. Could be fluid, as long as it lets you access your config file, because we're gonna have to edit those. You're gonna need another web browser screen and go to beacon3d.com. In the documentation section at the top, click on Quick Start, and then we can start. We're gonna need your favorite SSH client. I'm using PuTTY, and connect it to your printer. Let's connect mine. Alrighty, I'm connected. I'm just gonna switch the screen together like that, left and right, and we can start the installation. First thing first, we need to install the Beacon Klipper module, and they have made a script for that you're just gonna have to copy on your Raspberry Pi. I've already installed that, but you got the point. You install this, and then second thing you're gonna need is the Moonraker Update Manager. This is only optional if you like to have your Beacon setup automatically update through the Klipper automatic update feature. Moonraker will take care of that, so you just copy that into Moonraker, you're good to go. Okay, now we need to configure Beacon for Klipper, so we're gonna add this section under our printer.configuration. I'm just gonna go at the bottom and start adding this. So it wants to know your serial ID for the Beacon probe, so we're just gonna go under PuTTY and we're gonna list the device serial, and then it's gonna be by ID, and we're gonna list everything. And the first one is our Beacon, so we can copy paste that right here, replace that. All right, that is good to go. And then we need to set our offset for the probe. So in my case, the probe's gonna have 0 in terms of X offset, and it's gonna have 27.065 if I remember correctly. Yes, that's exactly it. And I've put those on GitHub for both the CNC VZ printhead and the printed one. So if you want to check that out, it's right there. I'll put links in the description, don't worry. Okay, and then the mesh direction, we're going to do a mesh in X. You could also do it in Y if you prefer that. In my case, I'll do X. And the number of times it's going to scan the bed, 2 times is better. Okay, good. Next thing we need to do, or we need to add, is Z-Save homing. You might already have that in your config file. I personally didn't have that because I was not using a bed probe. So we're going to use this guy, and we're going to set the middle of the bed. In my case, it's a 235 bed, so the middle is 117.5, and the Z-hop is going to lift the head or move down the bed 3mm, just in case it doesn't scratch the nozzle to the bed plate, and you're good to go. Okay, next thing we need to add, as per the documentation, is to add this in your stepper driver for your Z-axis. So we're just going to do that. I'm going to add this, and what it does is going to add a virtual end stop pin. And since we were using on this printer a physical end stop pin, we're going to have to disable that and get rid of that. So we're just going to comment out the those two right here. Doesn't need to know that. We're not going to use the end stop pin as we were before. And it's also doing a homing retract distance of 0. So in my case, I had one already homing retract distance. We're going to comment that one out, and we are good to go. All right, we now need to add a mesh section. So if you had a probe section, delete that. You're not going to need that. Beacon section will replace that as per the instructions. So in our case, we're going to go again at the bottom, and we're going to add a bend mesh section. And you need a bend mesh section, and they specify that right here, require bend mesh. So what we're going to do the algorithm by cubic. I think that's just the default anyway. The speed at which you're going to probe the bed, and in my case, I'm going to go with 500. Slower the better, but I think it's good enough. That probe is good enough to do it at 500 millimeters per second, and I went even crazier, and we might experiment with that speed later down the video. So for now, 500. And then you need to define the minimum position of where you're going to probe and the maximum position where you want to probe. Keep in mind that you need to leave a little gap on the sides of the bed, because otherwise it's going to probe in the empty space, and you don't want that. So in my case, I left a 15 millimeter on left side, and I've set the minimum at 30 since my probe offset is 27.6. 30 was good, and the maximum as well on X and Y. And then the last section is the number of probing point that you want to define for your bed. 15 by 15 for a small bed like that. 235 by 235 is quite decent for what I do. You could crank that up if you wish, or I could even lower that down. It's going to take less time to do, but it's going to be less precise. 15 by 15 is just a good start, and you can play with that later if you want. And now we are ready to save and restart Klipper, and we can go with the calibration of the probe. So let me just restart. So Klipper has restarted, and we are ready to do the calibration of the probe. It's always best to do the calibration when your bed is set to your normal operating temperature. If you print more PLA, then just set your bed to about 60 Celsius. If you print more with ABS, well, just do it with 100 Celsius maybe, or just use a temperature that you wouldn't normally use for your printer, the one you use the more often. In my case, I'll set it to 100 Celsius because that's what I use. And I will leave the printer soak a bit and let it heat, so every component inside the printer will expand and take its position and be ready for for the calibration. So I'm gonna leave it probably a 5 to 10 minutes just for the main calibration, and we're gonna do the calibration after that. So I'll just switch computers. I'll go in the print room, and we're gonna do the calibration together, and I'll show you how that's done. Okay, the bed has been heating for a bit of time. I had a coffee break. So we are ready to go to the calibration process. We first need to home both axes. So let's just do that. And we need to bring the print head to the middle of the bed. All right, and we can run the beacon_calibrate now. There you go. When you do this, it should pop up a command like so. And what you see there, that 200 is my maximum Z height. So this step, what you need to do is to bring your nozzle as close as possible to your bed. And you can use a piece of paper to find the right spot for that. So let's just bring the bed up on this case. Again. All right, from now on, I'm going to move close to the printer and use my mobile with mainsail. I'm going to give it another millimeter and another one. And now it looks like it's touching the bed, but I'm going to use a piece of paper. And now I'm going to use increments of 0.1. All right, this is what you need to do. You can feel restriction a bit on the paper, on the nozzle, and that is where you want it to be. So you click on accept, and what it's going to do, it's going to home the Z right there, and once it's done, you can store the configuration. So you can hit that save config either from your Klipper screen or from the mainsail interface. So we're just going to do that. Save. And it's going to restart Klipper. And if you're wondering if that worked or not, you can go and check your printer.cfg. At the bottom of your file, you should see that new config that was just saved. So it did very good. It stored that, and we can go on now with the bed mesh. So let me just bring back this guy. The next step is to do, well, you could query your beacon probe, but we know it's working. We just did it. You could do, again, a homing. You could do the probe accuracy. Well, let's just do this. That's pretty cool to see. Paste that. Probe accuracy. Oh, yeah, we just reset Klipper. So let's just going to do home all. And the probe accuracy will do the accuracy test, and you'll be very surprised on how precise it is. So let's just do that. It's going to do it a couple times, and it doesn't need to move. It can query the probe every time like that, and it's going to give you a deviation like that. Well, this time it's a bit more than what it was giving me before. Let's do that again. Yeah, that's way better. Yeah, that's really crazy. And now you could also test the beacon, the backlash in your Z system. That is a command that you can run. But we are interested in doing a bed mesh calibration right now, and you are ready. Let's do that. And it's going to be quite interesting. So, and it's starting, and it's doing it at 500 millimeters per second. And it's quite awesome. I've never seen something like that. It's going to do a total bend mesh with less than like 30 seconds. I didn't calculate the whole thing, the whole process, but there you go. It's done. And if you want, you can now store that value inside your Klipper, either from the Klipper screen. I'll do it from Klipper screen this time. So you hit continue, and it's going to store it on your Klipper config file. And if you want to take a look at what it did, you can open your printer.cfg and go at the bottom, and there you go. That is your bed mesh, and you can also visualize it from the menu. This is the mesh that we just did, so we're just going to load it, and there you go. How cool is that? I like this. There's a couple hiccups here and there, but the deviation is minimal, less than 0.1. We can scale it to better. Yeah, that looks good like that. And the cool thing about it is it lets you see the imperfection on your printer. As you can see here, the two lines here probably means my X-rail is getting ready for being replaced, but it's actually not that bad. The deviation is minimal. So that was it, folks. In less than 20 seconds, we got a complete bed mesh, and it's ready to print. The last thing to do, you're going to launch a print, and you're going to notice, you're going to watch your print, and if it's too close from the bed, you're going to use either Klipper screen or mainsail, and you can go do macro adjustment of the Z height, and after the print is done, you store that into your printer, and it's going to store it into your printer configuration. So that was it. That is Beacon, and the good thing about it is now, well, since my bed plate are pretty flat, as you can see, I don't really need to do the bed probing, but though I like it because it's a cool tool to have in your toolbox. But now I'm going to be able to swap PEI sheet plates between different models, and I launch a print, print's done, remove the bed plate, put a new one, launch a new print, and the sensor there will just sense the new bed plate height, and it's going to be perfect. So that is a good plus for me. Other than that, yeah, it's an awesome product from NX Engineering, and I'm sure you will like it too. But we cannot stop there. We need to see this thing do a mesh at something more crazy than 500 millimeters per second. Don't you agree with that? Let's just do this. Okay, I think we're going to do it at, let's see, we have at 500. Let's do this at, yeah, let's do this at 2000. Will it be able to do a probe at 2000 millimeters per second? Let's see that. And we're also going to, well, hold on. We need to crank up acceleration for that. Let's go to 30K. And let's do a bed probe, a bed mesh at 2000 millimeters per second. All right, we are ready to do this. I had a little typo in the config file, but I fixed that, so we are set to 30K and we are ready to do this. We're just gonna hit the calibrate. We're gonna name that bed mesh 2000 and we are ready to launch it. Are you guys ready? Let's do this. Oh, that's cool. Woo! Let's see what it looks like. Let's see what that looks like. Oh my gosh. It actually looked pretty good. I thought it would had like more issues reading, but let's compare that to the one at 500. It looks almost the same. Except, yeah, we have a point where it goes deeper here, in the back, right here. But other than that, it's kind of crazy. It worked. It worked pretty good. So that was it. A bed mesh at 2000 millimeters per second. Oh man, that was so cool. I really like that bed probe. It's amazing. It's light, it's ultra fast, it's precise, it's simple. All those qualities are just good for me and what I do, and I think it's going to be good for your printer as well. Even though now the question is, do you really need it? Do I really need it? That is another topic. My bed plates are good quality. They are ultra flat. So I've never really needed to do bed mesh, but what I do need now is having the stop switch. I'm going to use that probe as a stop switch, so that way it's very easy for me to just swap the bed plate, put a new one, because I have PEI sheets, but they're not from all the same vendors, so they have different thickness. So in the past, I always had to readjust my mechanical Z stop switch. Now the stop switch is going to be on the print head, just adding a couple grams, so it's good, and it's not affecting my input shaper result that much, so I'm good with that. That's going to be a good Z stop switch for me and what I do, but also it's going to be a good troubleshooting method or a troubleshooting tool to diagnose issues with things like your X-rail, for instance. You can see very precisely, the resolution on that probe is very precise, that you can see if you have an issue with your rail, even on the y-axis. So that is going to be a good thing for me. So if you want to buy it, I will definitely recommend it. If you want fast bed probing, that is the new tool to use. So it's very awesome. And that was about it for that probe. So I'm very happy with it. I even ordered another one for my VZ330 there, because yeah, I like it that much that yeah, I'm gonna use it. So good job there, Annex Engineering and the Beacon guy. You did a awesome product, and I'm very happy with it. So thank you for watching. If you have any questions, anything you'd like to discuss, leave a comment down below. If you like that video, drop a like. If you didn't like it, well, drop a dislike. And hopefully this video will help you to install it, configure it, and make it happen. So on this, folks, I wish you all a good night. Thanks for watching this one, and see you on the next video. Have a good night. Bye-bye.